Assalamu alaikum. In this video, we'll be talking about the object-oriented programming. So let's start with we're doing Java. So let's start with the basic class in Java. Let's call it program 1 Java. Let's create a main function in Java. Create a main function which going to be running whenever we code. So let's start with the basics. Let's do a quick print of this test. I hit F5 to run it. It did print test, which we asked it to print. Okay, so good. So in any programming language, you can just create functions, and then you have if statements. You can divide things by functions. Why do we really need a class? One of the reasons we need class is to put things together. Right now, it's a simple program, right? It's just doing the print, nothing much. But let's say we are talking about now. Give you an example of employee management system. We have a lot of employees. We have a way to manage those. Or for a lot of people, it's going to be easier to just understand the school because everybody has been school. So you have a school and you write program for school, right? So let's say you have a student, and for each student you need a function, for example, to add a student. So we will say the function name going to be add right. So it's a public student. Right. So we have a function for add a student. We would have a function for removing that student, right? So we would do a full quote kind of deal. Add, remove, then change or update. Going to be so for students, we're going to have three functions. For example, add would take some, it will take some params. And if you don't understand Java much yet, so basic introduction is here. Public means that this function can be accessible anywhere. And then void means it's not going to return anything. A function sometimes return something. So in this case, not going to return. If it would going to return, then we would have a type of thing that's going to return. Then they have a function name, right? So it's basic stuff. And here we can have the function body. So here we can have some parameters. Let's say we have a parameter called name, right? And then we can have maybe it would be ID. And some other stuff can be there, right? Address or guardian names or something. So all those going to be there. So, and then we will use those. Probably we have a database connection. We will add a code here to add that record. So for example, I would have a function and not in this class, somewhere else in the program. I will call that, I'll say add row. And we would add the row, provide whatever is needed in that function. So you got the idea. So we have right now, similar to this, a few functions. I'm not going to be implementing everything, it just show you, right? say remove, say add, remove, and then update, let's say, right? So now we have three functions for students. Now you would say, okay, we're done with the student side of things, and we need these certain specific things, and all of them would have different. For example, to remove a student, we don't need a name param. If ID is there, that's enough. ID can be used to delete the student from the database. And update would depend. Right now, I just create a simple update student function. It could be multiple things update. Let's update the guardian information or update the phone number or address of the student. It could be different functions, or this could be a function which can take a lot of parameters. Same for the student. Anyway, so these are all student related. Why do we have only student related functions? Why not we create a function that can add anybody in the database? It could be because the student have some other restrictions. For example, for students, we need age. Students, we need which grade they are, right? And other specific things which other functions for adding other database may not need. For example, we would need similarly these three functions for a teacher. We want to add a new instructor in the school. So we'll say, or teacher in the school. So we'll say add teacher. And again, teacher won't have a grade. Teacher age may not matter. So we won't have those specific params. Let's add the age here. So we are kind of giving the example which we need. But for the teacher, we don't need the age. You need name, probably need their experience, maybe highest level of experience, maybe bachelor's. We'll say, okay, string, maybe their degree or something. But age in this case doesn't matter. So then we would have remove teacher. Let me take this ID. So right. And then we would have an update teacher, and here we would have probably a degree as well. So this function would update. And this function, the other good reason we have the separate functions instead of just combining everything in one, because you may be calling different database tables here, right? So anyways, and there could be different checks. For example, we have some if statement for students. We want to check if the data is correct. We just not want to get the call, go directly to database without any checks. So we would have different checks for students, different checks for teachers, and so on. So right now we just talked about the students and teachers. What about the guardians? We have student guardian information. So they have their own addresses, phone numbers, other details, addresses. So we would have similarly functions for those, right? Let me do a quick replace. So would have another set of functions for guardians, right? But in the guardian, we don't need but their phone number may matter. So it's phone is very important whenever the guardian is being used. That's a must field. And again, this is just an example. In real world application, you would have a ton of parameters here. So anyways, also, because it's just an example, you may need a ton more than this functions. For example, a student is moving from one grade to another grade. So you'd have a move or update student function for grade only, maybe, because you want to do certain checks over there, which is going to be different than journal update of student function. Same with all of them. Teacher is getting certificates or other information. They're upgrading their career. So we want to have that. And teachers may have salaries. So we have functions related to salaries. So all of these going to have, for right now, we have only three functions for each type of um, person, each type of entity in our program, but we may have a lot more entities in our programs, and each of them may have a lot more functions based on the requirements. So now, what do you think? Is it better? And what do you think in this case? Um, would it make sense? Is it manageable to have a ton of like 20, 50, or 100 functions right here in one class? Or it's going to be better if I come here and say student Java, and then I say, okay, we're gonna have name, we're gonna have name as a doesn't do, for example, we're gonna have type name, another one, and ID, we'll say ID, right? And then we will say we would have getter setters maybe. So setting these properties. Um, I haven't used VS Code for um, adding the code. So we'll say, right, we would have get ID, we'll have set name, set ID, right? So you would have getter setters, you would have a constructor and stuff. But the whole idea is now that you can have so this is when you're saying update this name and ID, that can be your uh, update function. Oh, sorry, your get function, so you can get the information when you need a student from the ID. We'll call this one. Um, and you would have all other functions that we put in here. For example, add, remove, update. They're not going to be here anymore in this class, right? What it means you come here and you would create. So tell me what is better. Is it better to have 50 functions here and then a new developer come to your team? He doesn't know where the functions are, or you are looking at the code after writing it after 6 months or 1 year, and you're trying to find which function should I update from these 50 functions or 100 functions. In the big companies, there can be thousands of functions, huge application. Think about a game, for example, GTA or something. You know, it has cars, it has people, it has so many graphics, so many different objects and entities. You think all those functions of thousands of functions going to be here easy to manage? Probably no. But if everything is managed and divided into classes, and you come here and you look at uh, the student class, you know all the student related functions going to be here. And then simply the thing that we were doing previously, we can do it here as well in our main function. For example, whenever you say, okay, somebody click the button and this function has been called, and now we want to add a new student. So we'll say student, I'll say uh, base student, for example. And this will create the student for you. And then you want to add the name or do anything. For example, we would calling add student. That function is right here. And we can provide the name. We'll say, hey, name gonna be Hamid, and ID gonna be 1 or whatever is it, and age is whatever 10. Oh, and it could be arguments coming from here or somewhere else. And then your student is now created. This is the base student. You can do whatever you want with it. And this, when we create the student like this, it's called uh, And this class, when we create a class, um, uh, it's an object. So this student is a student class, but it has a sort of bunch of random functions and random string. They become a group. That group is called an object or a class. Got it? And this way, everything is first of all properly managed. And now, whenever I want to use these set of functions, all I have to do is to use it like this. So it's more reusable, more manageable. Now, reusability is the key in programming. I don't want to write a bunch of things that are not reusable. So that's the concept of base, class, and object-oriented programming. Here's the start. Here's the base. So you would have another class for teachers. All the teacher-related specific functions going to be there. It's the same. You can have another class for guardian maybe, and then all the guardian-related functions and properties going to be there, right? And I'm not going in detail what specifically these are called methods, and these are called properties, and what properties does and all that, because there are a ton of videos out there for that. But I want to give you the reason why do we create a class. We create a class because it's not possible to have thousands of functions in one place. Also, it's not reusable to create a function everywhere we want. No, we want to be able to create a reusable class, and then it can be packaged and deployed anywhere. This is the base class. You might have heard the concept of subclass and superclass. So right now, we have, for example, add a student function, and it is specific for a general student. For a general student, we only need an ID, age, and name. But that's may not be true if it's a high school student. For example, for a high school student, we must need, or for example, for a primary school student or a very young student whose age is less than 5 or something, we must need a guardian information to be passed to the function. You cannot just add a student, because a student can just that small cannot go to school by himself or herself. So we need more params in this one. So how can I use the student function, reuse the add student function in a way that it can support those specific small young students? So in that case, you will create a subclass, and if the class, it can say anything, but let's say it'll say primary student. So it's a primary class of student who's a young boy, young girl. So create the function for that. Create the class for that, and then we'll say it will inherit or extend. It will extend, and different programming language use different keywords to extend or create a subclass or inherit subclass. And in Java, we call it extends. So we are extending the base student class. What does it mean when we do extend? It means all the properties here and all these functions, they are now available in this newly created class. So I don't have to don't have to use all the functions and implement them here again. I don't have to write the same code again. That code automatically comes in because of just writing this keyword. And now I want to add a new function. Let's say, for example, for primary school student, we need to, for some reason, create a routine, right? So it's a public void add routine. For some reason, we needed this specific function for primary students, not for rest of the student. The rest of the student doesn't have that functionality, that feature. For example, let me give you a separate example for the subclass and having a new method in it. Let's say you're writing a code for GTA, right? You have a game GTA, and it's a vehicle. It's sort of a student class. You have a vehicle class. You come to the vehicle class, and then you see it has a lot of functions. Some function will say move the tire, some will say open the door, and each function when it's called, then that function happens. The door of the car opens when you hit that function, right? But some vehicles are not does not have only those functions. For example, if it's a truck, it has some kind of extra thing it can do. For example, it's a truck that can lift some, it has some tool at the front which can lift up something. So you have that function will say, so you would have the base class going to be vehicle, but you're going to have a truck class, and that truck class inherit all the function. It will say move tires, open doors, and all that function is going to be there. On top of it, on the truck class, which will extend the vehicle class, and it would have all the functionality of the vehicle, but it can also, let's say, would say lift some weight maybe, right? It would say lift, right? So you have this extra function lift weight, which is specific feature for that new type of class. It's a new function which can be only called in this class, which is a truck class, but not a base vehicle class, because not all the cars have that. But you have a tank, it's another type of vehicle. So it would have move tires, open doors, all that type of functions. But at the same time, it can shoot some fires, right? It can fire on the other vehicle and other people and stuff. So that would have other functions. So that's why you create subclasses to add more features. The other thing you can do with the subclasses is to override a function. Override means, let's take that example now a little seriously. We have this vehicle class. It's a vehicle.java. To have this class, then I will create a let's create a drive function. Right, so this is a function. It means it's a vehicle it can drive, right? And then you have another function which means it can open a door, and it will take door number, right? To open the door specifically. So this vehicle function it's common throughout all the vehicles, all different type of vehicles. They have all the same functionality. But let's say you have a truck, a tank, let's say, or Java, and it has all the functionality as well. You want to be able to open the doors, you want to be able to drive it, but at the same time it can do more, right? So that's why, because we're going to use the same functionality, we'll make it a subclass. We'll say extends vehicle. So now, what it means, if I come here, let me write a function which is unique for this one. And we'll give it, it's going to be void, it can do fire. Okay. And then let's say now we want to go to our program one to use it in our main function. Let's say I can do vehicle, or I can do, for example, so you understand vehicle going to be used like this, right? There is another way you can have vehicle here and a tank here, but that's a little advanced. Let's not cover it right now. Here we want to create a tank type of object. So your tank is, we'll say, a tank. This is going to be black tank, for example, or new tank. So my tank. Any name is just a variable name, doesn't matter. New, and then it's a tank. So you have new tank now, and now this tank, if I say my tank, so you see it has access to the drive function. Even though tank, I don't have drive function because it extends the vehicle. So that is the reason we use subclasses, because then we have access to the other functions. We don't have to rewrite all of them again. Got it? So that's the subclass, and that's why we use it. But this tank can also do fire if I want to. You see. Um, so that's why we use subclass versus superclass, so it can inherit. In our typical example, we're just going about the students. Different type of students can have different subclasses. So we don't have to write all the basic functions, but anything unique, which is a new feature, you write it. Sometimes it happens, it's a new scenario. Sometimes it happens, we want to be able to give same feature, but going to be different. For example, tank not gonna open the door same way as the other vehicles because it's a tank. It doesn't, the door, it doesn't work the same way. It has, so the code here, so let's say you're writing GTA and the car door opens differently, but the tank can open from the top. Usually it opens from the top and the stuff. It's not the same exact door. So let's say you want to change what the code you have in open door for the vehicle, and you want to write a new door, but only for tanks, not for all the vehicles. All other vehicles going to work same, but the tank open door is going to be different. So now what I would do, I will write here, I will say, I will give it a name, open door. As you see, a certain type of recognize that I'm trying to override a function. So now I would say, let's say in all the functions, let's print something. So when we run them, you know which one is being run. Let's say it will, let's see if it can do the get class. So now I come to the program one. First of all, let me see if my code is working. The new code for the tank, and I would say open door. Go here to F5. So you see, I call open door, and what in the tank, I'm just getting the class name, and you see what class is printed. It called the tank open door function, not the vehicle open door function. So let's type some code here in open door as well. Let's put the same code. Right. But if I would have another class, let's say tank is one type, but let's say we have SUV, SUV.java. This is another class. It has a new function, which is the how the back door opens, the trunk opens differently. So I have that function here. When trunk, okay. So I implemented only open truck here. I didn't implement anything. I didn't implement, for example, open door here, just open trunk. Now let's go back to our primary function. Where did it go? Program one. So I have a tank. I do the tank open door. So let me print here. Uh, I like copy pasting. Say um, tank door. Okay, that you print then. Also, I want to change all the print functions. Print means it will print a line. Uh, yeah. So, otherwise it will print the next thing right here, right next to it. I don't want to do that. I want to go to next line, then print. So all of these become print line. So now you like open door for uh, SUV. So first we were doing open door for uh, tank. Now I want to do open door for SUV. You can, for the consistency, you can definitely do what I was doing, but I want to keep it clean. Now we want to do it for SUV class. So we have new SUV, and let's change it, give it a name. SUV, just a variable name. So we are opening a door of SUV and opening a door for tank. It's giving a problem saying it's undefined. Let's go to SUV and see why open the error come in saying SUV doesn't have open door. So if you come here, we don't have open door, of course, but we were expecting the vehicle gonna do it, but we didn't mention the vehicle being extended, so it doesn't find the function here. So um, it's it's not finding it, so it's telling me it's not there, right? So it shows another good reason to use classes. Let's say if we had only functions but not the class, now it will be a little difficult to understand and function name gonna look weird. We'll have open door for vehicle this, open door for vehicle this, right? We have like 10 different functions for 10 different type of things, but now it's very easy to understand that if the open door function, let's say a vehicle is driving, and when the door opens on the game, it doesn't look right. So as a developer, I have to go and fix the function. So I can look at the vehicle, it's an SUV, and I can go to SUV function, try to fix it, right? So that's another good reason to find the, it's easier to find the code. Otherwise, we'll have to go through all the functions, look at the names to guess what the name might be, and stuff. You know what I mean? Here now, while I'm doing the extend, what I can do, I can just say, hey, what are different subclasses for the vehicle? So the easiest way is to just do extends, and then we'll say vehicle, right? So right now, when I do the find, it's only finding one class, which is extending the vehicle, which is the subclass of vehicle, which is tank. So if I were to search this, I will find all the subclasses. So there's another good reason to use the class system and object-oriented programming, because now I know, okay, which are the classes which can have open door, usually their vehicle, and we can see, okay, which are the sub vehicles. Let's say one of them is not working in the game. Now I'm trying to find the code, and I look at in the game, it's an SUV. But I guess it's an SUV. Let's say you have 10 names here. We'll look at one of this, like SUV. So let's go to the code and see what the SUV code looks like, and that open door function in SUV class. So I'm not going against tons of thousands of functions written in the big place, in the big file. It's all divided into logical order. So now that open door is not there, and when um, SUV function, I realized, oh, we forgot to extend the vehicle. That's why we don't have all those features. But as soon as I edit it right here and I go back, it should recognize this. Why it's not recognizing? Let's go back to SUV, and it does extend vehicle. Let me dot door again. Okay. So why it's not recognizing? Because our vehicle open door function have a number, right? So it so we wouldn't provide a function. So what it was expecting that there should be another function without an int, which we don't have. So here it needs an int. We'll say, hey, open door number 0, for example, or 1. So now, even though in SUV class, we don't have open door, but it's taking all the functionality from all the functions from vehicle class. That's why we can call it. And now let's run it. So what should happen? It should first of all say open door, right? Opening tank door. And then it's opening the door for the tank. So if I go to open door in the tank class, what does it say? It should print the tank class right here. When you try to open the door, that's what it should do. Then we come back to the program. It will create a new line. Let's add a dash in between so it's more clear. Right. And then we'll say open door for SUV, and then it will call a open door function within SUV. But if I go to SUV class, it doesn't have an open door function. So what it's gonna call, if I control and click on open door function, you would know and it's already showing it's gonna call the vehicle.open door because SUV doesn't have it. So when we have a function in the base class and we implement it again in the subclass, like we're doing in the tank for open door, it's called function overriding. So we have overridden the function. So when we call now tank dot open door, it will run this function, not the vehicle function. But if we have not done that, if we haven't overridden the function, we didn't override the function, like we didn't override the function in SUV class, then it will call the original vehicle function, which is going to be this. Now let's run it and see if what I'm saying is correct. So now, see here, it's saying, let's go to our main program. So first of all, like we said, open tank door, and then opening the door for the tank, and we are in that function, we're printing the class name, which is tank. So okay, so that function get called. But then the second one, when we say SUV.openDoor, it says class SUV. So it's in the vehicle, right? So that is fine. Even though we didn't use it, you see this function is being used over there. Now, say, instead of getting class, let's say side vehicle and tank. We have get class here as well. Let's call it tank, right? We're in the tank one. And we don't have anything in the SUV. We don't even have open, door function, but we have this open trunk function. Let's call it side SUV, right? Now rerun the function to see what it says. Okay, it says, now let's go back. It says open door. It called the open door function for the my tank, and you see it says inside tank. So that is being called, even though open door in the vehicle says what? Inside vehicle, but doesn't say that, it says inside tank because this function is overridden by the subclass. And now we do open door SUV right here. And then when we try to open the door in SUV, it's inside vehicle. Why? Because SUV doesn't override that function. So you get the idea of overridden. The reason you understood as well, because sometimes subclasses have slightly different functionality. So we want to override it to change the specific functionality. But why didn't we extended it? Why did we extend it SUV when we, it has the same function? I mean, why did we override open door in tank? Why did we extended the tank? Open door is different. The benefit of extending the tank, extending the vehicle class with tank is I don't have to implement all the functions of vehicle. Right now we have only open door and drive. So drive automatically comes to tank. I didn't have to implement it right here. Right now, vehicle class is right small, but let's say vehicle class had 20,000 different functions to do multiple different things. For example, vehicle can turn on lights, turn off lights, open doors, drive. It can drive forward, backward, right? Turn the wheels to left, turn the wheels to right. It can have like 20 different functions. And I don't have to implement all the functions again and again and again because I can just do extend. And if anything is being done differently for the specific type, I will override it. Otherwise, I will, if something brand new, which is not implemented in the vehicle and it only is the feature for this tank, then I will create that new function that will only be available in tank. So that's the reason overriding and subclasses and classes being used. There is another called overriding and it's called overloading. What's overloading is, let's say the vehicle, previously we have seen when we were calling the vehicle function, we wanted to, open door function, which is in vehicle, we have to provide a int, right? But let's say for some reason we want to be able to just, there is a type of class, type of vehicle which has only one door. So we, for that specific class, that specific type, we don't even need a door number. So we want people to be able to call the open door function without a number. So same name, but different parameters. If I come to vehicle, have the open door with int. I'll do open door without int. Right now I cannot have it because it's exactly the same. But as soon as I remove the parameter, it has the same name, but it doesn't have the same parameter, so it will take it. So now I can go here and it's my choice now. So whenever I call open door function, it will be called, this will be called. Let's say we would do some other code for and gonna be there, right? We will do something with this number is being provided. Over here, we don't have that provided, so we have a different code. So both functions are gonna have different code, but it will choose based on how I call it. If I call it with a number here, it will call that one. If I don't provide a number, it's fine. It will call the other function. That's called function overriding. So that's overloading versus overriding. Same with, let's say, vehicle. We have drive, and drive means normal start to drive, right? But you have a drive function, but it will be on a certain speed. It'll start to drive like 100 miles per hour right away because you're just using boost or something, or there's a feature. So you will say, okay, you have an int and speed will be provided here. So you use that speed to drive by that speed. Otherwise, you would have no function. So if somebody is calling a drive function on SUV, if you come here, I'll say, okay, now SUV, somebody press this button now, okay. Now I have a choice. I can do drive and provide the speed, the int, or I have a choice not to provide it. So, okay, basic driving. No, but not basic driving, we want speed. So it will speed with this, goes with that speed. So that is overloading. Overloading means you have two functions, the same name, but different IDs, and based on what we need, right? Same with the student class. Think about it. We wanna update a student, right? So update could be update name and ID. It could be update, have a, let's say update uh, class, say grade, right? When you say their grade needs to get updated and that grade is in int, first grade, second grade, third grade, which grade they are in. So I don't have to write the different names. I'll say update a student, and based on what input I would have, it will show me And based on those, I will call the function. So for example, I will create a student here. So student one, for example, student. So now for this student, I want to say, okay, update. Now I have a choice. You want to update their name or update their grade. As a developer, it's much easier for me to do it. So simple words, a lot of times you can do a lot of features without having these classes, but it's impossible to maintain in a bigger ecosystem where we have thousands of millions or sometimes um, a lot of code. Um, let me search how much code do we have for, let's say, Windows. I'm running Windows right now and running the code inside Windows 10. So if I search lines of code in 10, just doing a Google on a different screen, it says around 50 million. So imagine 50 million lines of code is there, and all different functions are just in one place. It's just in the main class. Yes, it might run, but let's say you're trying to open files for, you're trying to open Chrome, it's not opening. There's a problem in your function. And as a developer, somebody asks you to fix that function. Which function you're going to look at, it's going to be different. But now you know the file explorer has a problem, so you have a file explorer class, and all the file explorer related functions going to be there. So automatically try to look for the file explorer class. You say, okay, this is the class, and you have this somewhere open file explorer function or open window function. You say, okay, or you may have some overloading and overriding or something, but you know these are the 5 functions, or you have these 3 functions or 1 function to look to fix the problem. You don't have to go through all huge code. Also, it's very manageable. The memory, because, for example, right now we have everything in one folder, but a huge project can be multiple folders, namespaces, and all that. So you would want to include, you sometimes have seen includes or imports on top of the programming language, on the top of the code structure, right? So you would only import those specific things you will need. So you would have, let's say, in this area, in this place of coding, you're only working with vehicles. So you would import only vehicles. So all the vehicle related stuff can be imported, but not rest of the program, because the rest of the program has millions of lines. You don't want to include everything everywhere, right? So that's another reason to use object-oriented programming. Hopefully it makes sense. Talk to you later. Thank you.